Hello, geometry students. Mr. Zacek here. We are in Unit 3, Lesson 2-4. This is going to be our final lesson here on how do we prove that lines are parallel. And so what we're, just to kind of answer this question in a general sense, to get us thinking right here, what we need to prove that lines are parallel is we need a unique angle relationship along one transversal that cuts through both lines. And so essentially we can get that with if we have corresponding angles that are congruent, if we have alternate interior angles that are congruent, or if we have same side interior angles are supplementary. So they add up to 180 degrees. So what we're looking for is along a unique transversal that cuts through both lines, we need to find one of those angle pair relationships. Okay, so in the last lesson, we had one set parallel and we were trying to prove the other parallel, and in this lesson we switch it around. So I want to bring your attention here to proving this, and I'm going to highlight those in yellow, and if you have a highlighter I would recommend that you use it. So we're trying to prove the yellow highlighter, and let's start with the green. Okay, this is what we're given. So our given is the green. So let's mark the other thing. So if we're going to mark this, because those are parallel, we can put a little triangle on there. You'll see that in your textbook. That's an indication of parallel. And we also know that angle 6 is congruent to angle 11. So right now the issue that we have, or the barrier that we have, is that in order to prove T parallel to S, we need to have a pair of angles along a unique transversal. So I totally messed this up with my colors. So somebody's probably, you're there and you're like, Mr. Zacek, you did the wrong colors. And you're right. Okay, let me just correct it by doing this. Okay, so our green, this is our green, and our given is up here. All right, I apologize for that. Okay, so it's good to look at it twice. Good kind of lesson there. All right, so I know that L is parallel to M. So here's something that we can say. Because L is parallel to M, let's look along a transversal. I'm looking along transversal T, and I see, well, 2 and 6 are going to be congruent because those are corresponding angles. And now for T and S, now if we look along this top yellow line, line L, we notice that 2 and 11 would then be congruent, and that would give us that the lines are parallel. Okay, so that gives us our unique angle pair along a specific transversal. So I'm going to write this out, and don't have a ton of room here, so try to write small. So L is parallel to M, angle 6 is congruent to angle 11 because that's given to us. All right, step 2 is going to say now that angle 6 is congruent to angle 2, and the reason for that is if two lines are parallel and cut by a transversal, okay, cut by a transversal, then corresponding angles are congruent. Okay, so now, since 6 is congruent to 11 and 6 is congruent to 2, we could say that angle 11 is congruent to angle 2. Okay, and we can do that with substitution, or we could say that's transitive. Either one of those works. Okay, now here's the key, and we need to see this. Since 2 and 11 are congruent to each other, you got to see how 2 and 11 are along line L, and line L is the transversal that cuts through T and S, and so therefore we can say T is parallel to S because alternate interior angles are congruent. And we write it like this. If two lines are cut by a transversal such that, so if two lines are cut by a transversal such that alternate interior angles, so alternate interior angles are congruent, then they are parallel. Okay. Now, that is, again, our last statement is the thing we're trying to prove. That is not the only way to do this question, but it is one way. There's a whole bunch of different ways that you could approach it. So I'm just trying to give you some different options here as we look at this. All right, we're going to do one more of these type, and then we're going to jump into ones where it's a little bit same side interior. Okay, let me see if I can get my highlighters right. Okay, so given L parallel to M. So this is our given, L parallel to M, and I want to prove T parallel to S. Okay, so this is our prove. So if we mark it up now, I've got angle 1 congruent to angle 13. Okay, so on my given, I'm going to go this way. It's, again, we could do like 13 and 9 would be one way. I'm going to do 1 and 5. Okay, 1 and 5 are a pair of corresponding angles, and T is cutting through my given parallel line, so those are going to be congruent, and then therefore 5 and 13 are going to be congruent, and that's on line M. Well, line M is a transversal that cuts through T and S, and those are corresponding angles, so therefore this is going to be parallel. Okay, so let's write this out. Again, I know in this type of proof the statements are going to be a lot shorter than the reasons, so I'm just going to kind of offset this a little bit so we can fit it on our paper. All right, so let's start off with our givens. L is parallel to M. Angle 1 is congruent to angle 13. Okay, that's given. All right, and now I can say because L is parallel to M, we can say that angle 1 is congruent to angle 5. And so what pair are those? That's corresponding angles. So it says if two lines are parallel and cut by a transversal, then corresponding angles are congruent. So then corresponding angles are congruent. All right, now what can we conclude from the angles? We can now say that angle 5 is congruent to angle 13, okay, by the substitution property or by the transitive property. Okay, and now angle 5 and angle 13 are along this transversal. It cuts through the two lines, and angle 5 and angle 13 are a pair of corresponding angles. Okay, so we can say that T is parallel to S because if two lines are cut by a transversal such that corresponding angles are congruent, okay, then they are parallel. So if two lines are cut by a transversal such that corresponding angles are congruent, then they are parallel. Okay, let's jump ahead now. There's a couple more, you can do them for practice, okay? Same type of thing. Notice the difference between 2 and 3, the given switches, okay? And we kind of did that from the previous lesson, so I'm not going to do those. But now we're going to get into a different type, and it's given that angles 1 and angle 3 are supplementary, we want to prove that A is parallel to B, okay? So again, the same question here. How do we prove that two lines are parallel? We're looking for a unique angle relationship along one transversal. And those angle relationships are congruent corresponding angles, congruent alternate interior angles, or supplementary same side interior angles. Okay, so let's kind of fill in these reasons and talk through it. Number one is given. Okay, now number 2 says angle 1 and angle 2 are supplementary. Well, why would that be? Well, if two angles form a linear pair, then they are supplementary. Okay. And this is one of those things, supplementary. This is one of those freebies, okay? You can just see that from the diagram that angle 1 and angle 2, well, they're along this line and they form a linear pair, okay? Now, angle 1 and angle 3 are supplementary, angle 1 and angle 2 are supplementary. What we want to notice is that they're both supplementary to angle 1, so therefore they have to be congruent to each other. So the reason is going to be if two angles are supplements of the same angle, then they are congruent. So if two angles are supplements of the same angle, then they are congruent. All right. Now, once we've proven that angle 3 is congruent to angle 2, well, what unique pair is that? Those are corresponding angles. So if corresponding angles, that's what we have shown right here, okay, corresponding angles are congruent, we can now say the lines are parallel. So if two lines are cut by a transversal such that corresponding angles are congruent, then they are parallel. Okay, then they are parallel. Okay, so another way of getting there, and we've got one more question, okay, and it's angle 1 and angle 2 are supplementary, and we want to prove that A is parallel to B. So let's try that one out. All right, angle 1 and angle 2 are supplementary. Okay. So in the next step, the reason says if two angles are supplementary, then they add to 180. So they add to 180, that statement has to connect to whatever comes after then, And that's just going to look like the measure of angle 1 plus the measure of angle 2 equals 180. Okay, so because they add to 180. All right, now angle 1 is congruent to angle 3. What do we know up here? Well, those are vertical angles. So if two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. Okay. Now, the measure of angle 1 equals the measure of angle 3. Okay, that's if two angles are congruent, then they have equal measure. All right, now, what do we know? Okay, well, we're trying to prove this, and one of the unique relationships would be that these two angles right here, those are same side interior angles. So one of the three unique relationships we can use to prove is if those are supplementary. So we're trying to prove that. Well, here's what we see. Angle 1, measure of angle 1, what does that equal? The measure of angle 3. So the measure of angle 3 plus the measure of angle 2 equals 180 by the substitution property. Okay, now what do we know about those two angles? Because they add up to equal 180, then they are supplementary. So we can say angle 3 and angle 2 are supplementary. Okay, now same side interior angles are supplementary, therefore the lines are parallel. Okay, and this is our first time using this reason. To be honest with you, it's not used as much. That's why we didn't do it as much, but we do need to know how to do it. So if two lines are cut by a transversal such that same side interior angles, a lot of writing, are supplementary, then they are parallel. Supplementary, okay, then they are parallel. Okay, a little bit, just a few minutes longer here. Okay, but this is going to help you with some of the assignments where you see these types of questions. And now we've covered all of the reasons that you can use to prove angles congruent. All right, so good luck on your assignments and your labs and the upcoming quiz.